Hey there, science fans! Welcome to another exciting journey into the wonders of our planet. Today, we're diving deep into the ground to explore the rumbling world of earthquakes. These natural phenomena have fascinated and terrified humans for centuries. In the simplest terms, an earthquake is a sudden shaking of the Earth's surface. But there's so much more to it than just the ground moving. Imagine shaking a rug really hard. That's kind of what's happening, but on a much larger scale. The Earth's crust is like that rug, and the forces at play are incredibly powerful. This shaking is caused by movements deep within the Earth's crust. These movements are the result of tectonic plates shifting and grinding against each other. These movements release a tremendous amount of energy in the form of seismic waves. These waves travel through the Earth, carrying the energy far and wide. These waves travel through the Earth, causing the ground to shake and sometimes even split apart. The intensity of this shaking can vary greatly. It's like dropping a pebble in a pond and watching the ripples spread out. The initial impact creates waves that move outward, just like seismic waves during an earthquake. Earthquakes can range from tiny tremors that you might not even feel to massive events that can cause widespread damage and change the landscape. The magnitude of an earthquake is measured on the Richter scale, which helps us understand its power. Some of the most powerful earthquakes in history have reshaped entire regions, leaving behind a trail of destruction and altering the course of rivers and mountains. Understanding earthquakes is crucial for learning how to stay safe when the ground starts to move. Knowing what to do during an earthquake can save lives and reduce injuries. Scientists around the world are constantly studying seismic activity to better predict and understand these natural events. Their research helps us build safer structures and develop early warning systems. Communities also play a vital role in earthquake preparedness. Regular drills and education can make a big difference in how well we respond to an earthquake. Advances in engineering have led to the development of earthquake-resistant buildings, which are designed to withstand the forces of seismic waves. These innovations are crucial in minimizing damage and saving lives. Remember, being prepared and knowing what to do can make all the difference. Stay informed, stay safe, and keep exploring the incredible world of science.
So, what exactly causes these earth-shaking events? The answer lies beneath our feet, in the Earth's tectonic plates. Picture the Earth's outer layer like a giant jigsaw puzzle. The pieces of this puzzle are the tectonic plates, and they're constantly on the move, albeit very slowly. These plates are like giant rafts floating on a sea of molten rock. As these plates move and bump into each other, they can get stuck. Imagine pushing two pieces of sandpaper together. They grip, and pressure builds. When that pressure becomes too great, the plates slip past each other, releasing a burst of energy that causes an earthquake. Most earthquakes happen along the boundaries of these tectonic plates. It's like a cosmic fender bender between these massive chunks of Earth.
Now, how do scientists measure the strength of an earthquake? It's a fascinating process that involves some very sophisticated technology. They use something called a seismograph. This device is crucial in the field of seismology. Think of it like a super-sensitive detector that picks up on all the shaking. It can detect even the smallest tremors that we might not feel. The seismograph records the vibrations caused by seismic waves. These vibrations are then translated into data that scientists can analyze. These waves come in different flavors. P waves, which are fast and arrive first, and S waves, which are slower and pack a bigger punch. P waves, or primary waves, travel through both solid and liquid layers of the Earth. S waves, or secondary waves, only move through solid rock, making them slower but more destructive. They cause the ground to shake up and down and side to side. The data from the seismograph helps scientists determine the earthquake's magnitude. This is a crucial step in understanding the potential damage and impact of the quake. Magnitude is a measure of the energy released during an earthquake. It's calculated based on the amplitude of the seismic waves recorded by the seismograph. The Richter scale used to be the go-to measurement, but now we use the moment magnitude scale, which is more accurate for larger quakes. This scale takes into account the area of the fault that slipped and the amount of slip. The higher the magnitude, the stronger the earthquake. For example, a magnitude 7 earthquake releases 32 times more energy than a magnitude 6. A magnitude 5 earthquake is 10 times stronger than a magnitude 4, and it releases about 31.6 times more energy. and a magnitude 5 earthquake is 100 times stronger than a magnitude 3. This exponential increase in strength and energy release is why even a small increase in magnitude can mean a much more powerful and potentially devastating earthquake.
When an earthquake strikes, you often hear about the epicenter, but what exactly is it, and how is it different from the hypocenter? Think of it like this. The hypocenter is the earthquake's underground point of origin, where the rock first breaks along a fault. It's like the bullseye deep within the earth, where the seismic waves originate. The epicenter is the point on the Earth's surface directly above the hypocenter. It's like dropping a stone in a pond. The point where the stone hits the water is the hypocenter, and the point on the surface directly above it is the epicenter. Understanding the difference between the epicenter and hypocenter helps scientists study earthquake patterns and assess potential risks.
Section 5. Global earthquake zones, where earthquakes happen. Earthquakes can happen all over the world, but they're much more common in certain areas. These areas are called seismic zones, and they're found along the boundaries of tectonic plates. One of the most seismically active areas on Earth is the Ring of Fire. This zone circles the Pacific Ocean and is responsible for about 90% of the world's earthquakes. It's like a giant earthquake-prone belt around the Pacific. Other earthquake-prone areas include the Himalayan mountains, the Mediterranean Sea, and the East African Rift System. These areas are constantly shifting and grinding, making them prime locations for earthquakes. Knowing where earthquakes are most likely to occur helps us prepare for these events and build structures that can withstand their power.
Section 6. Predicting the unpredictable, earthquake forecasting. Imagine if we could predict earthquakes with the same accuracy as we predict the weather. Unfortunately, earthquake prediction is a complex and elusive goal. While scientists can identify areas at high risk for earthquakes, pinpointing the exact time and location of a quake remains a challenge. It's like trying to predict when a bubble will burst. You know it will happen eventually, but you can't be sure exactly when. Despite the challenges, scientists are constantly working to improve earthquake forecasting. They study fault lines, monitor ground deformation, and analyze historical data to identify patterns and potential warning signs. While we can't yet predict earthquakes with certainty, understanding the science behind them and being prepared for their potential impact can save lives.
Section 7. Before the quake. Preparedness is key. When it comes to earthquakes, being prepared can make all the difference. Remember, we can't stop earthquakes, but we can take steps to stay safe when they happen. First things first, create an emergency plan with your family. Decide on a meeting place in case you get separated and make sure everyone knows what to do during and after a quake. Next, assemble an emergency kit. This kit should include essentials like water, non-perishable food, a first aid kit, a flashlight, and a battery-powered radio. It's like packing a go bag for an adventure, but in this case, it's an earthquake adventure. You can also earthquake-proof your home by securing heavy furniture, installing latches on cabinets, and knowing how to shut off your gas and water supply. Section 8. Riding out the tremors. Survival during an earthquake. Earthquakes can strike without warning, and knowing how to react can make all the difference in ensuring your safety and the safety of those around you. So, what should you do if the ground starts shaking beneath your feet? Remember the phrase, drop, cover, and hold on. This simple yet effective method can significantly reduce your risk of injury during an earthquake. If you're indoors, drop to your hands and knees. This position helps protect you from being knocked over. Take cover under a sturdy table or desk to shield yourself from falling debris. Hold on tight to the furniture until the shaking stops. If no shelter is available, cover your head and neck with your arms and crouch in an inside corner of the building. If you're outdoors, move away from buildings, trees, and power lines. These structures can collapse or send debris flying, causing serious injury. Find an open area away from potential hazards and drop to the ground. Stay there until the shaking stops, keeping an eye out for any dangers that may arise. If you're driving, pull over to the side of the road and stop. Avoid overpasses, bridges, and power lines, as these structures can be particularly vulnerable during an earthquake. Stay inside your car, which can provide some protection until the shaking stops. Once it's safe, proceed with caution, watching for road damage and other hazards. Remember, stay calm and follow these simple steps. Your quick thinking and preparedness can keep you safe during an earthquake. Practice these actions regularly so they become second nature. Being prepared can make a significant difference in how you respond when the ground starts to shake.
Section 9. After the dust settles, immediate actions and long-term recovery. Once the shaking stops, it's important to check for injuries and damage. Remember, aftershocks can occur, so stay alert. If you're trapped, try to get help by sending a text message or making noise. Don't try to move rubble or debris unless you're trained to do so.
If you're safe, check on your neighbors and offer assistance if needed. Remember, community support is essential after a disaster.
In the long term, be patient and focus on rebuilding. It takes time to recover from an earthquake, both physically and emotionally. Reach out for help if you need it, and remember, you're not alone.